In this video, we're going to go through the entire Calorimetry Lab report. So we've got the directions pulled up right here. I have my lab report Google Doc up. So let's start with the title. So the title says, give a descriptive title, avoid using verses in the title. The title should give the reader an idea of what the lab report is about. So title or Calorimetry Lab are not acceptable titles. It needs to be reflective of what we did in the lab. So I'm going to use ChatGPT and I'm going to give it some inspiration here. So I need help writing a title for my lab report on calorimetry. It even says the title should be concise, informative, and reflect on the main focus of the experiment. Okay, so here are a couple options. Now, these are okay, but they really don't talk about what we did in the lab. They're very vague. So in the lab, the purpose was to identify an unknown metal. So I'm going to include that. Okay, so it's going to try to tweak the titles a little bit. Okay, now if you look at number 4, notice how it has a colon there. So I don't like that. I'm going to exclude it. And I also want to shorten them up a little bit. The more you can tweak the title, the more information you can give AI, the better titles you're going to get. So these are some better titles. So I'm going to just grab the first one. You cannot use my title. You have to come up with your own. All right, so boom, there's my title. And I think that meets the guidelines. Okay, next, background information. It says, remember, background information is written in present tense. You need to cite your sources for any material you researched. Be sure to include the following information. So we have 5 questions here. The first being, what is specific heat? Now for each one of these questions, you're going to need to look up some information from the internet. If you ask ChatGPT or another AI to write your background section, it's not going to be correct. It's going to be too wordy. There won't be citations. So you're going to need to do some research on your own. So let's take the first question here and let's open up the Google and let's find the definition for specific heat. Okay, so I don't want to grab this one right here. This is just straight from Google. So I want to find an actual web page that has information about specific heat. So let's take this first source here from Britannica. And here we go, first sentence. Specific heat is the quantity of heat required to raise the temperature of 1 gram of a substance by 1 Celsius degree. Okay, so let's take that and go to the background section. Now, it is not okay, it's not okay to just paste in from the internet. Okay, even if I cite that, that's not okay. Your background section should not just be a bunch of quotes like that, right? You need to put it in your own words. Now, you could reword it yourself, or you can use AI to help paraphrase it. So ChatGPT is going to rewrite it. Okay, now that's fine. So I'm going to paraphrase here, and I still need to cite this. Okay, so there are websites where they will help guide you in the citation process. They'll do the citation for you. I find it's easier to do the citation by hand. So let's go down to the works cited, and let's do our first citation. So we are using APA format for our citations. Some sites like Britannica have a citation built into it, and if you click on that, it lets you toggle between MLA, APA, and Chicago style. So the format for APA citations is usually the author's name or the group name, the date of the publication, the title of the article, and it's always italicized, and only the first word is capitalized. So if you notice here, like this is incorrect. The first word should be capitalized. And then it's going to be the title of the website, which should not be italicized. And then the URL of the website. So if you look here, like this automatic citation that was generated for us is incorrect. And oftentimes those citation generators will generate an incorrect citation. So I find it's easier just to do them by hand. So let's start with the author's name. So it looks like the editors of Encyclopedia Britannica is our author here. So I'm going to start with that. So editors of Encyclopedia Britannica. That's our author. Okay. Now the year it was published. We actually have a specific date here, so it looks like 2024, February 27th. Okay. Next is going to be the title of the page. So the title is specific heat. All right, so I'm going to paste that in. I'm going to capitalize only the first word, and then I want to put this in italics. Okay, next is going to be the name of the site. So this is just Britannica. And then finally the URL. So this is where you just copy and paste from the address bar up at the top, like that. Okay. Now, when we do citations, we want to do what's called a hanging indent. Okay. And the reason we do a hanging indent is because when you have multiple citations, it's hard to tell, especially when they spill over from one line to the next, like the first one right here. It's hard to tell where one citation starts and the next one, when one citation ends and the next one begins. So to do a hanging indent, I'm going to highlight my citation. I'm going to go up to the top where you see this little triangle. I'm going to drag my triangle over to 0.5. And then I'm going to grab the little rectangle up top and I'm going to drag that back to, to 0. Like that. Okay, so that is called a hanging indent. So again, when you have multiple citations, every time you have a line that's flush with the left side, that's the start of a new citation here. So that's how we can tell. They should also be alphabetized by the first word. Okay, so for example, if this first word was apple, okay, so A first and then E. So we always want to make sure our citations are alphabetized in our Works Cited. Okay, so we're not done with our citation. We need to go back to the sentence that used that citation. So here's our first sentence right here. And I'm going to include the first word of our citation. So editors. All right, I'm going to paste that in. And then it's going to be comma, the year it was published. So 2024. That is called an in-text citation. Okay, so let me be clear. When you write your background section, you need to include citations. If you do not include citations, you will not get points for your background section because you either plagiarized the information or you had ChatGPT or another AI write it. So you have to have citations in your background section. Okay, just like that. So you should have a sentence or two for each of the questions in the background section here, and you should have citations for most of these. Okay, some of these you may use the same citation, others you might have to go out and find a new one. But remember, every single question needs to have some sort of a citation with it. All right, the next sentence, or rather the next section, is the purpose. The purpose should also be written in present tense. Your purpose should be one clear, concise sentence explaining what you are going to accomplish or figure out when you do the lab. Okay, so in the lab, our purpose was to identify an unknown metal using calorimetry. Say unknown metal using calorimetry. And metal, not mental. There you go. All right, so one sentence. The purpose of this experiment is to determine the identity of an unknown metal using calorimetry. Okay, and actually this is an investigation. So the purpose of the investigation is to determine the identity of an unknown metal using calorimetry. Done. Okay, the next section is the methodology. Okay, so the methodology should be in past tense. You are reporting on what you did. It should be described in a way that others could read your lab report, follow the procedure, and successfully duplicate the experiment. This section needs to be in the third person. The emphasis is on the lab and not the people performing the lab. This section is not a step-by-step protocol, so we shouldn't be numbering or bullet pointing our methodology. You should be summarizing in full sentences and well-developed paragraphs. The next section is the methodology section. So it says the methodology should be in past tense. You're reporting on what you did. It should be described in a way that others could read your lab report, follow the procedure, and successfully duplicate your experiment. This section needs to be third person. The emphasis is on the lab and not the people performing the lab. This section is not a step-by-step protocol, so you shouldn't be numbering or bullet pointing the methodology. Summarize what you did in full sentences and well-developed paragraphs. Okay, so I'm going to pull up the procedure right here. So these are the steps that were given to you during the lab, and you need to summarize these. So you can do this by hand, or you can use AI to help write this. So when you do this, if I just ask ChatGPT to write a procedure for the lab, it's going to be very vague and not specific, especially if I'm starting from scratch and not providing ChatGPT any information. So what I'm going to do is I'm going to copy the procedure here, and I'm going to put this into ChatGPT. So if I provide all the steps, oh, look at that. It started with numbers and it's bullet pointing. That's not what it's supposed to be. So if you just paste in the steps, notice right away it's not correct. So the more information that you can provide AI, the better it's going to do. So I'm going to let this finish up. And while it's doing that, I'm going to go back to the directions. When you provide AI information, it's good to provide the directions from the assignment. So I'm going to take the directions, I'm going to copy them, and when it's done, I'm going to paste in the directions. So let's see how it does now. Okay, so notice it's writing it in sentences, and it's written in past tense. It's also written in third person. This is excellent. So it's a little lengthy, but it's okay. There are also some big words in here like subsequently, but it's okay. Now you can also ask it to shorten it. So let's try doing that. So shorten the procedure to be more concise. So let's see if it does that. Okay, so again, it's written in past tense. It's written in third person. And it's shortening it up a little bit to remove some of the extra fluff that was included in the first time. Now, look at that last sentence. It says, this concise methodology enables accurate replication of the experiment. Like, that's an unnecessary sentence. And oftentimes, when you use AI, it'll include extra fluffy sentences like that. So when you are writing your methodology, it's a good idea to read through what's written, because ultimately you are responsible for what you're turning in, and you want to exclude sentences like that. So go ahead and take them out. So let me finish cleaning this up. I want to make sure they're in paragraphs. I want to remove all the extra spacing so it's nice and neat. And let's read through this. So in this experiment, a 600 milliliter beaker was 3/4 filled with deionized water and heated to boiling on a hot plate. Simultaneously, an unknown metal was weighed after zeroing the balance with an empty weigh boat, and its mass was recorded. Okay, so notice we have an underline here for grammar, but that's not correct. Okay, weight boat is not correct, so I'm going to ignore that. The metal placed back into a test tube was then submerged in the boiling water bath with the tube clamped and not touching the beaker bottom until the metal nearly reached 100 degrees. So far, so good. Okay, we don't have any extra fluffy sentences. While the metal was heating, a calorimeter made of 2 styrofoam cups was zeroed on a balance, and 100 milliliters of deionized water was added and weighed. The initial temperature of the water was recorded with a thermometer placed in the calorimeter, which was supported by a 400 milliliter beaker for stability. Okay, so again, so far so good. After the metal temperature reached at least 90 degrees, as verified by a thermometer, it was quickly transferred from the test tube to the calorimeter. The calorimeter was then covered and the temperature monitored until it stabilized at a new equilibrium, which was recorded as the final temperature of the system. Okay, so we have the word equilibrium in there. That's a big word, but I'm going to let it slide. Last paragraph. The metal was then carefully removed from the calorimeter, ensuring no loss of the sample. This procedure was repeated for a second trial to ensure data reliability. This concise methodology enables accurate replication of the experiment. So this last sentence right here is unnecessary. I'm going to go ahead and delete that. All right, and then also, if you notice, this last paragraph is kind of short. It's only 2 sentences. So I'm going to go ahead and include that in my previous paragraph. Okay, so perfect. So 3 concise paragraphs. That's great. So once you use AI, or if you use AI to write your procedure, you want to go through and read it, look for those fluffy sentences, and delete them because they're unnecessary. Okay. All right. The next section are data tables. Okay, so let's go back and look at the directions. All right, so data tables. Create 2 data tables to organize your information. The first data table should be the data you gather in the lab. The second data table should be the table of metals with the specific heat values. Remember, tables should be titled and include headings and units. Okay, so if I go back to my directions here, I have a sample data table that has all of my trials and information right here. So let's go ahead and build that. So it's looks like 6 rows and 3 columns. So insert table. So 6 rows, 3 columns. All right, and I want to make it look just like the data table in the lab document. So we have trial 1, trial 2, all right, and then we have mass of unknown metal, and the units were grams. We have mass of deionized water, so I'm just going to put water, grams. We have initial temperature of water. We have initial temperature of metal, and then final temperature. And this is going to be, I'll just put of metal and water. Okay, we need to include units. So for the degrees, you go to Insert, Special Characters, and on the Special Characters window, if you search for degree, it will come up like that. And I'm just going to copy this and paste it in where else I need degrees. Okay, so if you notice on my temperatures here, it goes to another line. So if I click on this line right here, where it separates the different columns, if I click on that line, if I click on that line and drag it to where everything fits on one line, you don't have to do this, but I think it cleans it up a little bit, makes it look nice. Perfect. Okay. Now, if you notice, column 2 and column 3 are not the same size. So there's a really easy way to make those columns the same size if you highlight the 2 columns like I just did. So click and drag. If you right-click on the table, there's an option for distribute columns. That will make them both the same size. Okay. So I'm going to go ahead and bold my top row here and center all the information. I'm going to do the same thing over here. I'm going to bold that. Oops, that spilled down to the second line. So again, I'm going to drag that over, distribute my columns. Perfect. Okay, now another way you can clean up your table to make it look a little nice is you notice this top cell is blank. There's nothing in it. So if I want to get rid of this line here, if I click on it, I can go up to the top where it says border width and change that to 0. I'm going to do the same thing over here to make it nice. This is unnecessary, or it's not required, I should say, but it looks nice. Okay, that is a fantastic looking data table. All right, and I'm going to go ahead and add in all of my data. So you're going to want to use your data from the lab. I'm just going to type in some numbers here. So I don't know, 10, 20, 25. Okay, but again, obviously you would want to use your numbers from the lab. So maybe it was 21 the second time. Okay, so I just threw some numbers in there. Obviously, you're going to want to include your numbers from the lab. We also need to give this data table a title. Okay, and your title should not just be data table 1. It should be reflective of what's in the data table. So again, I'm going to go to ChatGPT, create a title for this data table, and I'm going to put the information that's in that data table. If I just said to create a title for my data table, it would give me something that is not reflective of what's in there. So it says calorimetric data for unknown metal and water temperature measurements. It's kind of lengthy, so I might ask it to shorten the title. There. That works. It's okay. Not great, but it's okay. Perfect. So calorimetry results for metal and water. Okay, now we also want a data table for these specific heat values. Okay, so I'm going to need to create a second table. So if you look at the lab directions, it looks like it is 1, 2, 3, 4, 5, 6, 7, 8 rows, 2 columns. So insert table. So we said 8 rows, 2 columns. Perfect, just like that. Okay, and I'm going to make it look just like the data table. And I'm going to give it, oops, let's do the multiplicate. Oh, no, here's the dot I'm looking for, or that works. And then degree. Okay. And I'm going to fill in my values. So here you can copy the values that I'm writing because they're going to be the same. Okay, and again, I'm going to bold my top row. And to make this look nice and neat, I'm going to center my information like that. And again, I need a title. So I'm going to go to ChatGPT. Actually, that is a fantastic title. I'm going to take that one and I'm going to paste it in right here. Okay. Perfect. So I've got my 2 titles. I've got my 2 data tables. We are good to go. All right. Moving on. The next section is calculations. Okay, so for the calculation section, it says each calculation should have 3 steps. Step 1, write the equation. Step 2, substitute the known quantity with appropriate units. And then record the answer with correct units. It says be sure to include calculations for the change in temperature for the metal, both trials, the change in temperature for the water, both trials, and the specific heat of the unknown metal for both trials. And it gives you a little hint about inserting special characters. Okay, so when we did the pre-lab, we did these calculations. Okay, so we have a lot going on here. So I'm going to create some subheadings for my calculations so that I can easily tell what's what. Okay, so within my calculation section, I'm going to, let's do it like this. I'm going to underline, and I'm going to do change in heat for metal. Okay, so I just underlined that. Okay, and then I'm going to do trial 1. and trial 2. Okay, next I'm going to have change in heat for water, and then trial 1, and then trial 2. And then finally, I'm going to do the specific heat. Trial 1, trial 2. Okay. So I don't have to write out the equation each time. I'm going to do that first I'm going to put the equation above trial 1 and trial 2 for each step. So the change in heat for the metal, my equation is final minus initial. So I'm going to do insert equation. And remember, when you're in the equation editor, you're going to see that blue box around your equation. If you accidentally click outside of that, the blue box disappears, and notice the options up here disappear. So you can always just click back, or you can use the arrow keys on your keyboard to go back and forth. All right, so I'm going to find the delta symbol right here. So change in temperature equals, I'm going to do T. Now, to get to subscript, there's two ways. You can click on the box right here where it says XA, and it will drop you down. Or you can press on your keyboard Shift underscore. Underscore is the key to the left of the 0 key on your keyboard. And I'm going to type final. To get out of the underscore, you can just use the arrow keys on your keyboard. I'm just going to press the right arrow, and it brings me out. So final minus initial. That's my formula. Okay. All right. So for trial number 1, I'm going to go insert equation. So delta T equals, my final temperature for trial 1 was 30 degrees. So remember, that's the metal and the water. They're going to have the same temperature. So 30 degrees minus my initial temperature of my metal was 10 degrees. Okay, and again, you're going to want to use your information from the lab. And notice I don't have any decimals on here. I bet your measurements are a little bit more accurate than mine. I'm just using some really simple numbers here. All right, so 30 minus, oh, wait, was it 10? No, I'm sorry. That was the mass of the metal. It should be 100. 100 was our initial temperature of our metal. Okay, so 30 minus 100 is going to be negative 70, and my units are degrees. Celsius. Just like that. Okay, so I believe it says to substitute the known quantities with appropriate units. For this lab report, let's just include the units on our final answer. Okay, final answer. All right, so you would do the same for trial 2. I'm going to go down to the change in heat for water. Actually, that should be changed. Let's change that to temperature. There we go. All right. Same thing. I'm going to put my equation here first. So change in temperature equals final minus initial. And I'm going to show my work here. So new equation. So delta T equals, my final temperature was 30, and my initial temperature was 25. And again, I want to include my units on this. Just like that. Okay? All right, specific heat calculation. Okay, so this one's a little bit more complicated. So let's insert our equation. So our equation for specific heat is going to be minus, parentheses, MC delta T, and this is going to be for the metal. That's going to be equal to MC delta T for the water. Just like that. All right, now there's going to be probably a couple steps for this. So let's go ahead and substitute in all of our information. So we have the mass of the metal, which was 10 for trial 1. Okay, we are going to multiply that by the specific heat value for the metal, which we don't know. We're trying to solve for that. All right, times our change in temperature for the metal. which was 70, negative 70. We're going to set that equal to the other side. So the mass of our water was 20, it looks like. Now notice I dropped the parentheses. I don't have a negative on the right side, so I can go ahead and drop that, times the specific heat of water, which is 4.18. All right, and then the change in temperature for our water was 5. So the specific heat of water will always be 4.18. All right, so to solve this, if you notice on the right side, it is all numbers. It's all numbers. So we can multiply the whole right side of our reaction, or our equation rather, and then on the left side we have 10 and negative 70. Let's multiply those two numbers together. So I'm going to make another line and new equation. So 10 times negative 700 is negative 70 is negative 700 times C equals, and then let's get our calculator out. So we have 20 times 4.18 times 5 is 418. Okay, the two negatives are going to cancel out right here. So that'll just be 700C equals 418. And to solve this, let's divide 418 by 700. And we get 0.597. And again, you should be using your numbers. Now the units for specific heat are joules over grams times degrees Celsius. So you need to include units on your final answer. And I'm also going to bold. Well, I guess it doesn't bold. I guess I will just leave that. Now, just to make this a little bit cleaner, I'm going to move this equation down one line. So it's a little bit easier. You can also, if you want, indent your calculations. So it's a little bit easier to see the difference between trial 1 and trial 2. But that's up to you. As long as it's easy to read and it's not just a giant mess of calculations. Okay, so anything you can do to make it easier for me to read would be appreciated. So you're going to do the same thing for trial 2. All right, now, if you notice, we have all of the information here. So in the pre-lab, we had an average. So I'm also going to include on here an average specific heat value. So once you get your calculation for trial 2, you're going to want to average trial 1 and trial 2 together to get an average value. Okay, so to solve for your average, it's just your C from trial 1 plus your C from trial 2, and then we're going to divide that by 2, and that'll get us our average. Okay, so mistakes happen in the lab, and when we do multiple trials and then average them, we end up with a more accurate answer. All right, the next section is the conclusion. So the conclusion needs to be written in past tense and third person. You are reporting on what already happened. It begins by restating the purpose. Unknown should be identified in the conclusion. Be sure to include the unknown number and identity unknown. Your claim needs to be backed up with evidence gathered from the lab. How are you able to determine the identity unknown? Reference data tables and or your calculations. So let's restate our purpose. Okay, so let's take a look, and let's say that 0.517 was our average specific heat value. So 0.517, and our units are joules over grams times degrees Celsius. So let's do dot and degrees. Okay, so we calculated an average specific heat value of 0.517. And let's go look at the data table. So it looks like aluminum and nickel, it falls between aluminum and nickel. All right, so nickel's too low, aluminum's too high, but it's in between the two. And it looks like it's closest to nickel. So I'm going to go with nickel for this example. and it was 440, I believe. Yeah, 440. Let's copy and paste our units. Okay, so the purpose of the investigation was to identify an unknown metal using calorimetry. The average specific heat value of the unknown metal was calculated to be 0.517. According to the data table, nickel had the closest specific heat value of 0.440. So I can just maybe add one more sentence. There you go. So therefore, the unknown metal was likely nickel. Now notice I didn't use any of these words. Proven, true, correct, unproven, false, incorrect. Okay, so based on the data collected in the lab, nickel was the closest match. All right. The last section is explanation. The explanation section is written in past tense and third person. It is used to support the conclusion or explain the significance of the conclusion. Explain how the first law of thermodynamics is used to solve for the specific heat of the unknown metal. Discuss sources of experimental error, at least two. What could have gone wrong? Although you may discuss human error, the focus should be on the design of the calorimeter and how it affects efficiency. Provide recommendations to reduce errors for anyone who may repeat the experiment. All right, so let's start with the first part. So explain the first law of thermodynamics, or how the first law of thermodynamics is used to solve for a specific heat of the unknown metal. Okay, now if you take this and ask ChatGPT to write this, it is not going to do a great job because it's not going to know what happened in the lab. It's going to give you very vague, very general sources of error, and I'm not looking for human error. I want something specific. So you can ask it for ideas on what might have been a possible source of error, and you could think, well, did that happen in the lab? Is that something I observed? That's acceptable, but if you ask ChatGPT to write this section of your lab report, it's not going to do a great job. So, first law of thermodynamics is energy is conserved. It's never created or destroyed, it's always transferred. So, if you look at the specific heat calculation, remember the energy or the heat lost by the metal is equal to the heat gained by the water. So, the metal was heated, we put it into the water, and it raised the temperature of the water. Eventually, both reached the same temperature. So, with that in mind, you should be able to write a sentence about how energy was transferred. Okay, so first sentence, explain how energy is transferred in calorimetry. All right, next. We should talk about how we used that to solve for the unknown metal. Okay, and again, these are questions you can ask ChatGPT, but you should be writing this in your own words. Discuss sources of experimental error. What could have gone wrong? You need at least two. So again, if I use ChatGPT and I ask, what are some possible sources of error in this investigation? Let's see what it comes up with. So some of these we've discussed in class, like heat loss to the surroundings, making sure that we cover up our calorimeter, inaccurate temperature measurements, incomplete thermal equilibrium, so basically not letting everything stabilize, water evaporation. So lots of things here. Now some of these don't apply. Like number 4, for example, water evaporation. We didn't leave this out long enough to really evaporate things. I'm not looking for any human error. So it talks about measuring incomplete or poor measurements, thermal conductivity. Like some of this is a little bit too deep and some of this didn't happen, but this is a good start. Like number 1, great. Okay, explain it. Explain how that's a possible sources of error. Okay, now these should have actually happened in the lab. I'm not looking for crazy things that are a bit of a stretch, like some of the things ChatGPT mentioned. I want you to think about what happened in the lab. What were possible sources of error? Remember that temperature change. That temperature change is really the most important part of this lab. So what could have affected the change in temperature and given you inaccurate readings? All right. So it does mention here, although you may discuss human error, the focus should be on the design of the calorimeter and how this affects efficiency. So there are some human error potentials, like transferring the metal from the boiling water to your calorimeter. How would that affect efficiency? How would that have affected the change in temperature? Okay, finally it says provide recommendations to reduce these errors for anyone who may repeat the experiment. So thinking about the one we just talked about, transferring the metal from the boiling water to the calorimeter, what could you do differently to retain that heat so we're not losing any heat? Okay, would you want to do it slower, faster? Is there anything you can do in the process to eliminate any of that heat from escaping? What about when you put the metal into the water, your calorimeter? How do you keep the heat from escaping? What could you do differently? Okay, so those are the types of questions that you need to answer in the explanation. And you should be specific. Okay, and that's it. That's the full lab report. Okay, this is going to be fantastic. Good luck and have fun.